Hi, I'm Bob. Welcome back to 5 Minute Econometrics, a series designed to introduce fundamental econometric concepts, estimation methods, and identification strategies. We have just learned t-statistics and t-tests in the previous topic. Today, we will learn another method of determining the significance of a population parameter. It's about computing the p-values for t-statistics. We have just learned the first method to determine the significance of a parameter in a regression model. Given the significance level and degrees of freedom, we can directly find the critical value in the statistical table. Then we compare the t-statistic with that critical value and see whether the null hypothesis is rejected. However, in practice, most statistical software reports the t-statistics and their p-values. Computing p-values of the statistics is another method of determining the significance of population parameter. P-value is the smallest significance level at which the null hypothesis could be rejected. It can also be interpreted as the probability of observing a value as large as the t-statistic if the null hypothesis is true. For instance, if we obtain a t-statistic of 2 in a regression with 100 degrees of freedom, the corresponding p-value will be 0.024. It means we observe a t-statistic as large as 2 only 2.5% of the time if the null hypothesis is true. The p-value represents the area to the right of the t-statistic in a t-distribution. The probability of observing a t-statistic of 2 is only 2.5% if the true value is 0. However, we obtain that extreme t-statistic from our sample, which implies that the true value of the parameter is highly unlikely to be 0. Our sample gives strong evidence that the null hypothesis is not true. Therefore, we can reject the null hypothesis that beta equals 0 at a significance level as small as 2.4%. A small p-value is evidence that we can reject the null hypothesis. A two-sided alternative case is similar. The p-value for a t-statistic of 2 against a two-sided alternative with 100 degrees of freedom is 0.048. It is the shaded area of the graph. It indicates that we can reject the null hypothesis at a significance level as small as 4.8%. In other words, we can reject the null hypothesis at the 5% significance level, but cannot reject the null hypothesis at the 1% level. The p-value is twice in the 2-tailed t-test as in the 1-tailed t-test for the same model. All other things equal, it is more difficult to reject the null hypothesis in a 2-tailed t-test than in a 1-tailed t-test. We usually perform a 2-tailed t-test after OLS regression. For a 2-tailed t-test, the p-value is computed as follows for the above case. Where the probability of t greater than 2 is the area to the right of 2 in a t-distribution with 100 degrees of freedom. It can be computed in Stata using the t-tail function. Here are the formulas of the p-values for the 1-tailed t-test and for the 2-tailed t-test. Stata automatically reports the p-values for a two-tailed t-test for all OLS estimates after regression. We continue to use our wage equation as an example. The Stata results window shows that the p-value for a t-statistic of 21.41 with infinite degrees of freedom against a two-sided alternative is 0 to 3 decimal places. So, the null hypothesis is rejected very strongly. The return to education is significantly different from 0 at a tiny significance level. Let's take a look at the p-value of another variable, the dummy variable, very good health. Its p-value is 0.032. The base category is excellent health. The null hypothesis is that there's no difference in wages between the workers with very good health and those with excellent health after controlling for other variables in the model. A p-value of 0.032 means we can reject the null hypothesis at a significance level as small as 3.2%. Therefore, we can reject the null hypothesis at the 5% level, but cannot reject it at the 1% level against a two-sided alternative. We can also use the t-tail function to compute the p-values in Stata manually. The absolute value function is for the situation in which the t-statistics are negative. Today we have discussed p-values. Given a t-statistic, along with the degrees of freedom and whether it is a one-tailed test or a two-tailed test, its p-value is determined. In short, p-value is a probability. It's the smallest significance level at which the null hypothesis can be rejected. A smaller p-value provides stronger evidence we can reject the null hypothesis. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.